Okay, in this video we're going to be talking about the remainder theorem. And let's start out with these warm-ups, and they kind of are introducing us to the remainder theorem. So we're going to take this function f of x is equal to this. It first says divide the function by x plus 4. So let's remind you, synthetic division, we put a negative 4 on the outside. On the inside we have the coefficients 1, 1, negative 4, and 41. And let's go through the process. Bring down the 1, multiply by negative 4. We always multiply by this number. 1 and negative 4 is negative 3. Multiply by the negative 4. Negative 4 and 12 is a positive 8. Multiply by the negative 4 gives me a negative 32. 41 minus 32 is 9. So that would be a remainder of 9. So you get constant x squared to be x squared minus 3x plus 8 plus the remainder over what you divided by. Then they said, okay, now find f of negative 4. So we're going to take our function, we're going to plug in negative 4 here, here, and here, and we get f of negative 4 is equal to negative 4 to the third. I'm going to go ahead and multiply that out, plus negative 4 to the second, minus 4 times negative 4, which is also a positive 16, negative times a negative, plus 41. And when you clean that up, it gives you 9. Okay, number 2, same thing. We're dividing by x minus 9, so 9 goes on the outside. We have 7, negative 63. We have no x squared, so we have to put a 0 there. 9x and a negative 80. Bring down the 7, multiply gives you 63. 0, 0. Put them together gives you 0, still 0. 9 and 0 is 9. 9 times 9 is 81. Gives you a positive 1 as a remainder. So that'd be constant x squared, x to the third. So 7x to the third plus 9 plus the remainder over what you divided by. Now we're asked to find f of 9. F of 9 is equal to 7 times 9 to the fourth. We'll go ahead and plug this in. Minus 63 times 9 to the third. This will take a little while. Plus 9 times 9 minus 80. We do have to raise our 9s to exponents. So we have now 7 times 9 to the fourth, 6,561, minus 63 times 9 to the third, which would be 729, plus 9 times 9, and you could actually go ahead and do that, minus 80. Clean all that up, and you actually get 1. Now, you can look at those two examples and see if you see any connections there, and that's actually what we're going to be talking about today with the remainder theorem. Here's what the remainder theorem says. The remainder theorem, if a polynomial function f of x is divided by x minus c, like in the previous examples, we divided by x minus negative 4 or x minus 9. And notice I said x minus negative 4 because minus minus would be a plus. So if you divide by x minus some constant, then the remainder will always equal f of c. So look back up here. If you divide a polynomial by x minus negative 4, then and that's what we divided by was the negative 4. So the remainder will always be the same thing as f of negative 4. So dividing by this and plugging this in is the same thing. The remainder will be the exact same thing as what you would have if you plugged it in. Here, the minus 9, x minus 9, I divided by, I put the 9 out here. I got a remainder of 1. Well, what if I plugged in and found f of 9? Then I would get 1. So what does that mean? You could actually use synthetic division to evaluate a function. And this process, using synthetic division to evaluate a function, is called synthetic substitution. And that's what we're going to be asked to do here. Use the remainder theorem to evaluate f of x at c. So what we're finding is, what is f of negative 3? Well, how do we find f of negative 3? Another way that we can do it, instead of going through the process of actually plugging it in, let me clean that up a little bit. Because notice on that second one up there, that was pretty ugly plugging in that value. We can just use synthetic division to plug it in. How do we plug in -3? How do we find f of -3? Then just do this. Go through the exact same thing, exact same process you normally would. It also makes you really good at synthetic division. Bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add. All you've got to do is look at the remainder. If you were to plug in -3 in for all these x's, you would get -20. That's it. Let's work another one. This one says find f of 1. So we're going to use synthetic division to plug in 1. Now, you don't do the opposite here. You do the exact value. To plug in 1, you put a 1 on the outside, and you do 3, 2, 4, 3, 2, and -3. Now, that would take a while to plug that in. But the faster you get at synthetic division, notice how quick this is. 3, 3, 5, 5, 9, 9, 12, 12, 14, 14, 11 is your remainder. F of 1 would be 11. Find f of -5. To find f of -5, we put a -5 on the outside. 1, 5, -19, -23, and 0. There is no constant term. That 0 does have to be put there. Let me double check. We got everything. 1, -5, 0, 0, -19. -5 times -19 is a positive 95. 95 minus 23 is a 72. Now that's a little tricky. That's -360. When you combine those, gives you -360 as the remainder. So therefore, f, let me write it over here, f of -5 would equal -360. Number 6, we're asked to find f of -2. So put the -2 on the outside. 2, 4, 0, 2, -1. Always be on the lookout for missing terms. There's no x squareds. Bring down the number, multiply. 2, -4, 0, 0, 0, 0, 2, -4, -5 is your remainder. F of -2 is -5. F of 7 on the next one. 7 is what we're dividing by. We have 8x to the third, -5x to the second, 0 x's, -1. Bring down the 8, 56. 56 minus 5 is 51. 357. 357. 7 times 357 is 2,499. Subtract 1 gives you 2,498 is your remainder. So f of 7, 2,498. One more of these. Find f of 4. Plug it in. 4, -2, 7, 2, no x squareds, -1, and 8. Go through the process. -2, -8, -1, -4, -2 when you combine them, -8, -8, -32, -33, -132, -124. So f of 4 is -124. Now let me show you another perk of this. If you don't realize it, what you just did, you just plugged 4 into this using synthetic division. Remember what function notation is, inputs and outputs. When you plug in 4 into this function, you would get -124. So as you work the synthetic division, this is a point on this function. Same thing here, 7, 2498. When you put a 7 into this function, you get 2498. That's a point on this function. That can help us graph this function. Remember that as we go through the problems in the remainder of the chapter. Okay, number 9. Got an application problem. Says the number of tickets sold during this football season can be modeled by this function, f of x. It gives it to you where x is the number of games they've played. Use the remainder theorem to find out the number of tickets sold during the 7th. So we're asked to find f of 7. So we're going to plug in 7 into our function 1x to the third, -14x to the second, 72x to the first, and 68. So we're just simply plugging in 7 by using the synthetic substitution. 1, 7, -7, -49, 23, 161. So our remainder is 229. So that means we sold 229 tickets during the 7th game. Okay, number 10. The distance in feet that a person travels on a snowboard is modeled by this equation, where t is the time in seconds. Use the remainder theorem to find out the distance traveled in 1 minute. Now here's where people are going to get mixed up, seconds and minutes. We're asked to find out how far would you travel in 60 seconds, 1 minute. So we're going to divide by 60. You have 0.6 t squared. You have 10 t's, and you have no constant, so you do have to put the 0. Bring down the 0.6. 0.6 times 60 is 36. 10 and 36 is 46. 60 times 46 is 2,760. Combine that with 0 gives you 2,760. That's the number of feet that you would travel in 1 minute.